Hi children, good evening all of you. Welcome to the online session. We are going ahead with the first revision session on MCQ on the first topic of the first unit, that is nothing but relations and functions. Now based which I had put across to you all, I hope everybody is doing well, right? But this next 15 days has to be really a very work hard attitude in your mind, so that whatever the board exam is coming up on 20th, 22nd, whatever the date has been scheduled, I believe that everyone would be ready to take it by your horns. So guys, let us see this part clearly. So I had mentioned some specific point conceptually also, that is reflexive, symmetric, transitive, then R is symmetric, reflexive, transitive with equivalence relation, and this part, this already you know, okay. Now the right hand side part is a very important part. These are, you call it as pocket concepts. Pocket concept means what? You don't have to think much on these issues, directly you can just use the formulas and get the working. Now for example, if A has m elements and B has n elements, for everything remember the function or relation is from set A to set B. So set A has m elements and set B has n elements. Then the number of relations is given as 2 is equal to mn. The number of relation is 2 is equal to mn. Then total number of functions, this number of relations. So total number of functions from A to B is nothing but n raised to m. Keep that in mind. Then this is important. Total number of one function from A to B, and not B to A, from A to B. If n is greater than m, what n stands for? B elements, what m stands for? M elements, okay, keep that in mind. M elements of set A and n stands for elements of set B. If n is greater than 1, m, that is the B elements are equal or greater than elements in A, then I mean to say the number of one function, if it is greater than or equal to, then it is NCM combination, NCM. So n stands for number of elements in set B and m stands for number of elements in set A. Keep that in mind, don't do reverse, okay. NCM into m factorial. This is the number of one function, which if you see n is less than m, then the number of one function will be definitely 0. Now that's way. Total number of one onto function, this is very important. 1 as well as onto. See, this is nothing but 1 function. Total number of 1 functions on onto functions will be, it will be 0 if m is not equal to n. If m is equal to n, there is n factorial. It's as simple as this thing, okay. Now total number of many functions, we remember onto and many one, many one. So many function is n raised to m minus npm, right? I mean to say with you to use. So you can definitely use that and give your best for this. So this is a very important concept. I will share these notes once again with you all, don't worry about it. But let us start dealing with the questions, okay. As and when I will take you back to this particular performer and let us go ahead with one by one. Now just let us start now the first lecture. The first question starts up here. That is relation function. We are starting with MCQ 02. The specific idea of doing this is we are already done our relation function MCQ 01, right. So let us take the questions now. Now I have given a set of questions here. I don't want you to do, as we go on, let me just elaborate and try to work out with you all and how it goes. The first case, okay. Now suppose if I give you if I give you 5 minutes for working on it, okay. Otherwise I would like to do this part, and let us start with this case. The relation B in set A, okay, is given by R 1, 2, 2, 2, 1, 1, 4, 4, 1, 3, 3, 3 is what? Now see the options. Remember one thing, the concept is always sticking together, and let us work out one by one, okay. Now see the question first. Now if you see the options, all the options are given in terms of, I believe, reflexive, symmetric, transitive. So best case is, for these type of sums, what I would suggest is, reflexive, transitive, symmetric. Try for all three because the options are combined formats. Okay. Now first thing, so whenever an ordered pair is given to you, very easy to identify whether it is reflexive, symmetric, transitive. So, first of all, for this order 1, 1, 2, 2, 1, 2, 3, 4. So, relation is this. So, first let us talk about reflexive. Okay, I am talking about the first question there. Let us talk about the first one. I am talking about the reflexive part. Now, if you see here 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4 is there. So, in this relation 1, 1, 2, 2, because if you remember in the concept what we did, AA belongs to R, then it is reflexive. AB and its reverse both are present, it belongs to R, is symmetric. Then AB, BC belongs to R, then AC also belongs to R, is transitive. So, guys, so based on this, let us see how to work it out. Now, if you see carefully here, reflexive A has to be there. Now, what is my A? These elements of set A, right? So, R is nothing but 1, 1 is there, 2, 2 is there, 3, 3 is there, 4, 4. All elements has to be there. 1, 1, 2, 2, 3, 3, 4, 4. That means it is reflexive. So, AA belongs to R. So, it is reflexive. Similarly, let us talk about symmetric, even though they are not mentioned. Symmetric is what? Ulta pulta. 1, 2 is there, 2, 1 is not there. AB is there, BC is not there. So, even one ordered pair does not work. You can say 1, 2 belongs to R, but 2, 1 does not belong to R. So, therefore, it is not symmetric. It is not symmetric. Got the point? Okay. Not symmetric, so reflexive and transitive. See now, 1, 2 is there. Now, transitive means what is the point? AB is there, BC has to be there. I mean to say BC is there. Then you compare, AC should also be there. So, let us talk about first two. 1, 2, 2, 2. So, AB, BC. So, 1, 2 is there. So, 1, 2 is already there. Then let us take 2, 2. 2, 2, any other pair starting with 2, AB, BC is there, BC is there, BC is not there, ignore this because AB is there, any ordered pair starting with 2 is not there, forget that, it is ignored. Because if BC is there, then only AC has to exist, otherwise you can ignore that ordered pair. Then 1, 1 is there, 1, 3 is there, so BC is there, 1, 3. 4, 4 is there, 4, 4 is there, then no other pair starts with 4. So, BC does not belong to 4, 4. So, out 1, 3 is there, 3, 3 is there, 3, 3 is there, 3, 3 is there, 3, 2 is there, 3, 2 is there. So, I mean to say you can compare this ordered pair with this ordered pair also any way around. So, what I say is it is nothing but transitive, it is reflexive, transitive, but not symmetric because AB and BC is not there for any ordered pair. I hope you got this point clear. Next one, ABCD, then a relation R, AB, BA, AA on A is what? Again, there is a case of symmetric, reflexive, transitive, symmetric and transitive. So, there is no reflex, okay, reflex is also there. So, anyway, ABCD, remember AA is there, BB is not there. So, it is definitely not reflexive. I am talking for the second. Reflexive is not there, done. Okay, so third question is out of option. Then symmetric, AB is there, BA is there. BA is there, AB is there. For every ordered pair AB, the reverse has to be there. Then A is there, iska ulta is A. So symmetric is definitely there. So symmetric is also there. Okay. Now this first option and second option and third option doesn't work out. So symmetric is there. Now let us talk about transitive because transitive option is also there. AB is there, BA is there. AB, BC, AA is already there. BA is there, AA is there, so BA is already there. AA is there, AB is there, AB is there. I think transitive also work, so it is symmetric and transitive. So let me confirm, it is symmetric and transitive. I hope you are understanding what we are trying to work out. This is a very nice question, okay. Third one. Now look at the third question. What they say, for a real number x and y, so x r y is defined as, you define, right, you define that the relation is defined as x minus y plus root 2 is irrational number. Okay, so whenever you take any two numbers x and y, this is a defined part of relation, x minus y plus root 2 is an irrational number. So by the way, what the question is, then the relation R is what? reflexive, symmetric, transitive, none of these. So they are not said equivalent. So that will mean some will be not, some will be yes. But either you have to say reflexive, symmetric, transitive. So as there is only one option, even one gets correct. If one gets correct, you can just tick mark that directly, because there is no reflexive and transitive, reflexive and symmetric. It's not given that way. So let's talk about a simple one first, reflexive. Now reflexive means what? A, R, A, R, A, correct? Now if I say A, R, A, because reflexive means A has to be present, correct or not? A has to be present. So A, A. So what will happen? This will become A minus A plus root 2. If I put it this A, R, A is X, Y is also A here. So if I put in this particular defined part of relation, this will get cancelled. What happens? Root 2. So root 2 is an irrational number. So what does that mean? It means AA belongs to R, because when I put this A in this, it satisfies this particular definition part, defined part of the relation. So what I understand from here? I understand A belongs to R. Great. So what I am going to do? It is reflexive. So I don't have to look at other things, because it is only one choice. If there is a reflexive and symmetric, symmetric and transitive, then you can look at the other option. So I got the reflexive, I don't have to look at the other two things. So this is where you cut short your mental stress, mental tension, and at the same time definitely you save a lot of time. Otherwise, after finding it's reflexive, you will again go for symmetric, transitive, none of this. Why? It's only one options are there. I hope you got this point clear, right? So I hope you understood what I did over here. So let's take the next one. Consider non-empty set, the children of the family ARB. I am talking about the fourth question. Okay, ARB, where ARB, now see, ARB, how the relation is defined. A is brother of B. I am writing here, A is brother of B. This is what in relation is defined. Now, by the way, again here if you see, there is reflexive ko maro goli. They are given the conditions of the answers based on symmetric and transitive. So you just think about symmetric. Okay, symmetric. Now hold on. So symmetric में क्या होता है? Suppose AB is there. AB belongs to R. Then ulta also should be there. So A is brother of B. Is it true that B is brother of A? Can't say. Because if A is brother of B, there is a chance that B is a female. So A is brother of B, so how can a female be brother of A? So I can say BA does not belong to R. Because you have to take the all possibilities. They are not specified anything specifically as it. I think first person is brother of second person. So suppose this B is a female and this is a male. A brother is a brother of B, but in chances if B is female, then B may not be brother of A. B is sister of A. Understanding my point? So anyway, coming to a point, that possibility is there. That's the fine. Because in this case, they just said A is the brother of B. You getting my point? Okay. So I hope you got this point clear. Now, so symmetric, not symmetric, not transitive. A is brother of B. B is brother of C. So I think here it implies, right? A is brother of B. B is brother of C. Right? B is brother of C. So I mean it implies A is brother of C. So see, A is brother of B. B is brother of C. Right? So both B is male here. So whether A is brother of B, so that means A is a brother male, male, C, sister rendo, brother rendo, implies that A is a male. So brother of C. True, it's true. If A is brother of B, B is brother of C, then A is definitely brother of C. So whether the C is female or male doesn't make a difference. Ulta not possible. Getting it point? So that's why AC belongs to R. So I mean to say, what does this mean? Transitive, yes. So when I say symmetric and not symmetric and transitive, any option is there not symmetric and transitive? Here, transitive but not symmetric. So I mean to say this option will go fine with us. This type of question we have done before also, the number of equivalence relation. Equivalence, if you see here, you can't use this formula. This is number of relations, okay. There is number of equivalence relations. So I had done this part. What you can do is, see how many options I can directly tell you it is 5. The first option, now equivalence का मतलब क्या, reflexive हो गया. Reflexive means what? 1 1 is there, 2 2 has to be there, and 3 3 has to be there. Similarly symmetric, symmetric is there, what? 1 1, 2 2, 3 3, 1 2, 2 1, right, then 1 3, 3 1, then 2 3 and 3 2, all will be there in this. So I mean this is a second relation, R2, R1, R2. So might be this is possible, otherwise this is also possible, 1 3 3 1, right, this is also possible. So 1 2 3 4 and last is all are together. So total 5 relation. I think this we had done this question, I strongly remember, in our relation function MCQ 1. So if you are not understanding, just keep it for yourself and you can refer that lecture. I know you will not refer, but refer all the MCQ lectures for that particular topic. I will post the links for you all for relation function MCQ 01. Okay, this is 02. So let us see the next part. Quickly we have to wake up now. So I hope you got this point clear. Have a look at this clearly. So this is the way you deal with the question. It's not difficult. Specifically the options will give you a direction how to really push yourself through the solving part of the question. So let's take the next question here. Okay, next question comes up, guys. Think over it and see what happens. L denotes the set of all straight line brackets. Let R be defined by LRM. So first question I am talking about LRM. So L and M are straight lines. How is defined? L is perpendicular to M. This is a relation defined. Only if L is perpendicular to M for all values of L, M belongs to, LM belongs to L, line L. Okay. Now they are saying reflexive hai kya, symmetric hai kya, again any one option. Why? Because there is no need to work out all. Okay. So first of all let us talk about reflexive. Reflexive hai kya? See, L is perpendicular to M. Right. So what a reflexive says, LL should belong to R. Now how can a line be perpendicular to itself? Not possible. A line cannot be perpendicular to itself. So LL doesn't belong to R. Right or not? Because see, this LM, so this is my L, this is my M. L is perpendicular to L. How it is possible? A line will be parallel to itself and not perpendicular. So this is out of question. So reflexive, out of question. Then let us talk about symmetric. L is perpendicular to M. Can you say M line is perpendicular to L? Because in symmetric AB and ulta should both exist. So I mean to say L is perpendicular to M, M is perpendicular to L. Guys, are you getting this point? So I believe L is perpendicular, M is perpendicular, that means what? AB, BC both are in the symmetric. So that means directly second option I got, finish, symmetric. There is no need to look at anything of this. If you have one choice, if there are two choices, symmetric and transitive, transitive not symmetric, then you have to look for reflexive, symmetric, transitive all and then conclude based on what option suits it proper. Okay, good. Okay, I just took more space there, I'm sorry. So I hope you got this point clear. So this is the way you deal with the question. Okay. So I can say here L is perpendicular to M, M is perpendicular to L. This is LM and this is ML. Belongs to R. Therefore I can say symmetric. Tick mark. That's a tick mark. Don't mind that. Okay. Let us take the second question. A is 1 to 3. The number of relations containing. Now this is important. Now normally what we saw was the number of relations when M and L, A to A, this is A to A. So this is M, this is N, this is 3, this is 3. So I believe 2 raised to Mn, 2 raised to 9 relations I can form. But what they are telling condition. the number of relations containing 1, 2 and 1, 3. So you have to be careful now. Okay, so this cannot work. That is 2 raised to mn formula will not work because there is a condition about this. Only those relations which has 1, 2, 1, 3 into it. So let us see and quickly work out. You also think, I will also think on myself. Hurry up, fast. Let us see the second part now. Second question I am talking about. Think properly. So in this relation, you know, what I am trying to tell you is 1, 2 is there and 1, 3 is there. Think. Acha, hold on. They are telling which are reflexive, symmetrical but not transitive. Think over it and tell me what is the answer. Matlab, it should be reflexive as well as symmetric. So 1, 2, 1, 3 भी है इसमें, है क्या? Okay, reflexive में I know the elements are 1, 2, 3. So I know in reflexive 1, 1 has to be there, 2, 2 has to be there, 3, 3 has to be there. This is also there. So symmetric भी है ना, reflexive and symmetric. So symmetric भी है तो 2, 1 हो गया, 1, 3 है तो 3, 1 भी हो गया, right? But 2, 3 अगर आप देखोगे यहाँ पे, if I take 2, 3, 3, 2 will not be there. Just check, will not be R. I mean to say, they are telling how many relations can you form containing 1, 2, 1, 3 which are reflexive and symmetric but not transitive. So इसमें ये भी आ सकता ना, with not transitive. नहीं, 2, 3 है, you can, it is transitive in this case. So one of the pair will not exist here. So 1, 2 is there, 2, 1 is there, 1, 3 is there, 2, 1 is there, 1, 3 is there. Look at this. 2, 1 is there, 2, 1. Now look at, for transitive I am telling, look at this pair. 2, 1 is there, 1, 3 is there, but 2, 3 does not belong to R. That means this is not transitive. So reflexive is symmetric. So how many relations you have? Only one relation. So only one. Only one relation you can form where it is reflexive, symmetric but not transitive. Okay, basically it happens to be the same case as we did. The next part, third. So by the way, what is the option for this? I think this is the right option. Though again, let A, the number of equivalence relation containing 1, 2. So again, this is the same side of question what we did. So I will just mention this answer here. This is question number 8. There are two relations, equivalence relation we can form. So first is 1, 1, 2, 2, 3, 3. 1, 2 is there, 2, 1 has to be there. Then 1, 1. So it is two equivalence relation will be there, symmetric as well as, I mean to say reflexive as well as transitive. Anyway, that's okay. Now hold on. Now this is something important. Now see. A is finite set containing m elements and B is a set of n elements. What is the number of relations in this form? I had given you the formula in the beginning. Please go through the notes. I will share these notes with you all. 2 raised to mn will be the answer for this. So what I said, precise concept, because it becomes easy for us to directly write the answer without. So number of relation is 2 raised to mn and number of function will be n raised to m or m raised to n. Let us see. The total number of relation is 2 raised to mn and total number of functions from a to b is n raised to m, not m raised to n. Remember, m is a elements and b is n elements. Keep that in mind. Okay. So n raised to m. Okay. Now see, n raised to m. Now here, the A has 3 elements and set B has 4 elements. Okay, A has 3 elements and set B has 4 elements. Then the number of injective mapping. You know what का मतलब क्या? Injective mapping का मतलब क्या? Injective मतलब 1, 1 function. How many 1, 1 function you can form? I had given you that also. Look at this. The total number of 1, 1 function A to B if n is less than m. Remember, n stands for B elements, and here A stands for m elements here. Okay, m elements in A and n elements in B. So if n is less than m, matlab B ka elements less than. Now in this case it is not the case. Why? Let me just see the question there quickly. I'll just share with you what I am trying to tell you. Now look at this. This is my m, this is my n. So if n is less than m, n is not less than m, so 0 out of question. Now see, please understand this, please. Okay, this is my A set and this is my B set, keep that in mind. Okay, so this is my A set and this is my B set. Now in this case n is less than m, they are telling. Now it's not true, because I told you what are the situation here. I am sorry, what is the situation here? B was 4, so n is greater than m. I am just telling you correlate here, n is greater than m. So this is not the case. So this is the formula you have to apply. Now NCM into m factorial. NCM into m factorial. You have a calculator with you, but I will just show you. NCM, so I think it will be 4C3 into m factorial. Okay, so 4C3 everybody knows, NC3, this is nothing but 4C3 is n factorial, 4 factorial upon 4 minus 3 factorial into what? 3 factorial. Right? Otherwise you can use NPR formula also. So sorry, n factorial, 1 minute. What is the answer? I think 24 is the answer there. Oh, if m is equal to n, the number of 1 onto is different. The number of 1 functions from 1 function will be NCM into m factorial. N is greater than or equal to m. Okay. I think you have to solve this out. There is no other option. Okay. So you know NCR, everybody knows what is NCR. I am talking about the fifth one. NCR is nothing but n factorial upon n minus r factorial into r factorial, right? So 4 minus 3, 1 factorial, so 1 out, so 3 factorial, 4 into m factorial, 3 into 6, so 4 6 are 24 into 3 factorial, which is nothing but 24. Is 24 there? Yes, 24 is there. This is the right answer. So not a difficult one. Those notes are very, very handy, children. So just have a look at that. Okay, got the message clear? Okay, let us take the next question. Now A contains 5 elements, B contains 6 elements. Okay, the number of 1 1 and on 2. Wow. Now look at this. Now here I had given you a note, the total number of 1 1 on 2 from A to B. If m is not equal to n, it is 0. If m is equal to n, n factorial. Okay, keep that in mind. So here, now let us see the first question. 5 elements. So I think m is not equal to n. Now if m is not equal to n, then what is the situation? 0. Remember 0. See, if you want to have a look, look at this. If you have the notes with you, just see. If m is not equal to n, there are 0, 1 1 on 2 functions, 1 1 on 2. So 0. So I don't know whether option 1 1 on 2 ke liye 0 is there in that. So let us see. Yeah, that's definitely 0 is there. So this is the answer, 0. So therefore option number C. I mean to say the 12th one. Okay, hold on. Okay, great. I think you are getting that, right? So it's not difficult one. So that pocket concepts are very handy, and you can chew it as a candy, and I think that will really work out with you. Option number C I have written there. So just good. Which of the following from Z to Z is bijective? From Z to Z. What do you mean with Z? Can you tell me? I am just waiting for your message. Can you tell me now? Anybody can tell me? I am just waiting with my mobile phone here just for your response to understand. Z stands for rational numbers or integers? It stands for integers, right? Are you sure? Integers, right? Okay, great. So I think Siddharth, good. So look, which of the following from Z to bijective? Now what is bijective here? Now bijective matlab 1 1 and onto. Okay. Now let us take the function. Now the situation is, I will tell you by looking at the options, you can quickly tell me how it is. Okay. So there are two sets here. You know, this is Z, this is Z, integers, negative, positive numbers. Now hold on. If you take x, first let us talk about 1 1. Okay, x cube. Mind mein rakho. So x cube. So for every value of c, 1 cube is 1, minus 1 cube is minus 1, 2 cube is 8, minus 2 cube is minus 8. So can you tell me whether this can be 1 1? I doubt, because it is integer to integer, slightly okay, it is 1 1, no doubt about it, but let me see. Yes, it is 1 1, because minus 1 will give you 1, minus 1, then 1 will all give you minus 1. So I think every number has a distinct image, 1 1. But what about onto? Onto, see this, here you have set of integers minus 8, correct? So it is like this. So if I write y is equal to x cube, so x is nothing but cube root of y. You know, you have to find for this range, you have to find for onto, you have to write x in terms of y. So cube root of 8, cube root of 8 is what? Cube root of 8 is 2. But what is cube root of minus 8? Not existing. Cube root of minus 8 is what? Minus 2. So it does not work, right? So this possibility is less. This possibility is 100% not possible. Why? Because see, it can be 1 1. But onto ke liye, if you say onto ke liye, what I said, y is equal to 2x plus 1. So write x in terms of y. So y minus 1 upon 2 will be equal to x. That means you will get a fraction answer for value of x. But as x is only integers, not fraction, so x cannot be a fraction if y takes some number in some cases. That means this is also not possible. This is 1 1, not possible, because minus 1, the mirror will be 1, plus 1, the mirror will be 1. So I think in this case also, if you want to try it out, I don't mind, or onto is definitely not there. So I think this is also not the case. This is the case for this thing. So you might argue with me, sir, you got the option into the threshold and then working out. Can we try to work out directly? Let us see about 1 1. So let us talk about 1 1. Now 1 1 case, now I am just writing it over here. Now x plus 2. So x1 plus 2, I am talking about x1 plus 2 is equal to x2 plus 2. Cancel, cancel. So this is 1 1. Now onto, I told you. So y is equal to x plus 2. So write x in terms of y. So x is nothing but what? Y minus 2. Now ask a simple question. X is, if you put y as some integer, are you going to get x also as an integer? Yes, 100% yes. In this case it was not, because it was upon 2. Some numbers you will get integer, some numbers you will not get. But in this case, yes, you put y as any integer, then x is also integer. That means this y image is nothing but the codomain. The range is equal to codomain. So every value of y will give you the x value, some x value, some x value. So I believe that this suits best. So I think fx is equal to x plus 2 is nothing but the function where it is bijective. This is square, by the way. This is square. Okay. I hope you got this point clear. Okay. Now let us talk about the 14th question. Now I am just writing here 14th one, just for your information. They are telling f is 2 to infinity, Om Namah Shivaya, whatever stuff it is. They are telling fx is, then the range of f is what? Now this is important now. Remember, range means this is x value is domain, y value is range. Keep that in mind. Okay. Now that means if you take this equation as y is equal to x square. Okay. Now what I can do, this I can write y, see you are at x in terms of y for range, so that's the point. So I can write this as x square minus 4x plus 4 plus 1. So y is nothing but x minus 2 whole square plus 1. So I believe x minus 2 will be square root of y minus 1 plus 2. So x will be, in short, square root of y minus 1 plus 2. Now I have no issue, because range means something, the value of y into x in terms of y. So now hold on, domain is the value of x. Now in this case, what they take, let function be from 2 to infinity, r be the function defined fx. So what is the range? Now simple way of looking at it, look, this is root of minus 1. Okay, root of minus, so that means all numbers of this, whether x or y, has to come from 2 to infinity. So exactly you are finding out what should be the range. Now whenever you want to find the range, write x in terms of y. Now tell me, y can be defined when either y is 1, because if I take y as minus 1, so minus 1 minus 1 minus 2. So in short, as it is inside the root, I can say here that y minus 1 should be greater than or equal to 0. So y should be greater than or equal to 1. Because why? Because this cannot be negative. Na? Root of negative number is not defined. So I say y is greater than or equal to 1. So greater than or equal to 1 matlab 1 to infinity. Because y is nothing but the range and x is nothing but the domain. So once you get this information, I will find what is the value of y to make it meaningful. Domain how you find? What is the value of x which will make it meaningful? But here when you want to find range, you will say after getting the x in terms of y, you will find all the values of which will make this function meaningful. When it will become meaningless? Because there is a root of negative number will not be defined. That means y minus 1 should be greater than or equal to 0. So y is greater than or equal to 1, so 1 to infinity. Is there any case of 1 to infinity there? Yes, it is there. I believe this option. So understand, this type of sums are really a good sum, but definitely I will just give it only less possibility, domain and range, 11th standard part, but you have to just pick it up. It's not necessary it can, but if it comes, it's a simple question, that's why they had given this up. This is a nice question, let us see. Now pre-images. Now when I say pre-images, I will tell you. This is image, this is pre-image. Always remember that. So here they are saying it is 17 and minus 3. What is the pre-image? So function is given to you, y is equal to x square plus 1. Y is equal to x square plus 1. So pre-image of 17, that means this y value is 17. So if this is 17 is equal to x square plus 1, so x square is equal to 16, x equals to plus or minus 4. आ गया. But at the same time minus 3 is also given as the pre-image. What pre-image I mean to say, this is the pre-images of minus 3. So it is same thing, y is equal to x square plus 1, right? So minus 3, so minus 3 what is equal to x square plus 1, so x square is equal to minus 4, oh my god. So undefined, empty. So I think if you see the option here, I got 4 minus 4, this is different. Pre-images 4 minus 4 infinity, this is, no, this will not work, because 17 ka pre-image infinity diya hai, wrong. 17 ka pre-image what is there, plus or minus 4. So either this option or this option, but the other value of x is not defined. Minus 3 का 2 minus 2 नहीं, empty आ रहा है because it is undefined. X square is equal to minus 4, so not defined. Not defined. So what happens? I think this option will be the right option. So understand this. That's the way you have to look at this question. That's the way you have to deal with this question. So in fact 15 questions we are done. So almost case studies तो फटाफट हो जाता है. But as we go on, let us take the next question. Now this is a nice question there. I want to confirm this question because it is neither 1 1 nor onto. Now let me just check the n stands for natural numbers. Given a is equal to b minus 2. So a r b, that's what the relation is. Okay, a r b. So a b is equal to b minus 2. B is greater than 6. So b value is greater than 6. That is no doubt about it. Okay, that is given. Choose the correct answer. So this is one of the ordered pairs which should satisfy this. So directly also we can do. If it is 2 4, 2 4. So look at this. A is 2. This is 4 minus 2. But that thing b is greater than 6. So here this is b. So this is out of question because this is less than 6. Correct or not? 3 8. If you take this as b, this as a, just see whether it satisfies. No. 8 minus 2 is 6. But where a is 3. So this is also out of question. I am directly doing it. 6 8. Possibility is there. So this is 8 minus 2 is 6. It satisfies and b is greater than 6. So I think this true value. This will also not satisfy. This will also not satisfy. So for this question, I think the best way to deal is see whether it is satisfies or not. I think that's a good case for us to stand. 17th one. 17th one. Satisfy every equation. So I don't have to think too much on this relation. So there are some questions you can really bang it out like that. That's the issue. Okay. I hope you got this point clear. 18th one is definitely a good one. Definitely it is 1 1 onto. Okay. You think over it. Fx1 is equal to fx2. You know how to do m11. So basically, see, now let us talk about 18th one. It's just a revision for you. Now you know that fx1 is equal to fx2. So I believe x14 is equal to x24. So if I take the fourth root on both the sides, it will become x1 is equal to x2. Shortcut I am doing. So that is nothing but 1 1. Otherwise I can solve this out. I don't want to. Onto के लिए क्या I told you, y is equal to x raised to 4. For x will be equals to fourth root of y. Now use your brains. It should satisfy. This is my x, this is my y. Now y is real number. So tell me, if I put y as real number, you will definitely get x as real number. Agree or not? Y as real number, x will also be a real number in this case. So let me just check it because sometimes there might be a confusion. What are the options given to you? Let me see. F is 1 1 onto, F is many 1 onto, 1 1 to ho gaya proof. Let me see. Fourth root, okay, it's not square, right? It's not square. 1 minute. So hold on. Now in this case, x1 4 minus x2 is equal to 0. So I can say x1 square minus x2 square. So a square minus b square is x1 square a minus b into a plus b. Now this is something very interesting, equal to 0. So x1 square minus x2. So here look at this option. This is a minus b, a plus b. This is equal to 0. I took it here. Okay. So immediately x1 is equal to x2 and x1 is equal to minus x2. Means what? What I am trying to do? So 1 1 hoga hi nahi na, because one element x1 is having two images x2 and minus x1. So I am sorry for that because it was a fourth root. It didn't strike me. But you have to solve this way also. Okay, when it's if it's not 1 and more than 1, you have to solve this way and find out only x1 and x2 gives the result. So here x1 and 2, so 1 1 तो होगा ही नहीं है. तो ये f is 1 1, f is many 1 तो हो गया, ये many 1 हो सकता है. फिर 1 1 ये दोनों तो out of question है, right? So either this or this. Now just check whether it is not 1 1, it is many 1. Many 1 भी नहीं possible because x1 is x2 and x1 is minus x2. So only one option is there, is neither 1 1, not 1 1 nor onto. So it is something different. So onto के लिए you can work out, for example, y is equal to x raised to 4 दिया है. So I think look at this. Y is a real number. So x, does it satisfy? Not necessary. Real number, fourth root of negative number, not possible. Correct or not? So I think it will not work. So that's why it's not onto. So neither 1 1 nor onto suits better than any other thing with this. It was a simple question. Next one. This also we have done. Again, y is equal to 3x. So I'll just mention it here. So y is equal to 3x. So I think definitely it is 1 1. Why? Because 3x1 is equal to 3x2, cancel. So x1 is equal to 1 1 तो हो गया. Onto के लिए I wrote x equals to y upon 3. Now this is real to real. So I told you this is x, this is y. So if you take y as any real number, what will be x? X will be any real number, nothing will be undefined. So I think it is 1 1 onto. So quickly you can do it. It's not that you are going to waste your time or not understanding something like that. Okay, keep that in mind. Okay, got the point. Okay. This one is a bore question there because it's a cubic, it is also 1 1 onto. I want to take some more question and we'll come back to this question now. In this case too, I just want to take this part also. 1 second. Okay, this you already know. Can you solve this question on your own? I think this had come in your exam also. What was the pattern of the question? Pre-images of phi and minus phi. So phi and minus phi. So pre-image, so x value they are asking, y value is phi. So phi minus 1, 4 plus 2 minus 2. So plus 2 minus 2 is here. So this will be the, might be the question. Minus phi is there. Minus 5 minus 1 minus 6. So x square is minus 6. So x is root of minus 6, not possible, empty. So I think I just did this type of question to see is the answer. The domain of the function. Now look at this question. Domain of the function is what? So you know what is domain? Domain is all values of x which will make it meaningful. Right? All values of x which will make it meaningful. Now tell me when all values of x which will make it meaningful. So x should be what values, but it is square. So x will can stand for any real number. But 1 square is 1. 1 minus 4 root of minus 3, not defined. 2 square, 2 square, 2 square, 2 square is 4. 4 minus 4 is 0, no problem. Now x is all those values will make the function meaningful. But as it is only if it is x minus 4, there is no issue. But it is square root of x square minus 4. So I have to solve this out. So what will happen now here is just equate it to 0. So x minus 2, x plus 2 equal to 0. So the critical points are minus 2 and plus 2. So intervals you can see here, this is plus, this is minus, this is plus. So what do you think? Whenever there is greater symbol, plus interval will be the answer. So I think my input will be this interval and this interval. Right? So it is minus infinity to minus 2, right? 2 is possible. So union 2 to plus infinity. Check yourself, minus infinity to, so there is a mistake here, this is a minus infinity sign. So minus infinity to minus 2 and 2 to infinity. So I think, I hope you got this point. So what is domain? Domain is nothing but all those values of x which will make the function meaningful. So what x can take value as? What you do? Get the critical point. Because it is quadratic, I can do by this way and solve this part. So you know extreme right, 11th standard you have studied, plus, minus, plus. Greater symbol, plus interval is the answer. Testing method se bhi kar sakte hai, but let us not go and waste our time there. So just keep that in mind. Okay, so this is the way you go about it. Now this is based on composition of functions. I think everybody can do that part, right? So fx is given f of minus 2. Plus f of 0, plus f of 2, plus f of 5. Now hold on. F of minus 2. So if you see greater than 3, greater than 1, less than equal to 1. So this function, so minus 2, here it will be minus 2 plus f of 0. So f of 0 is here only, x is less than equal to 1, 0. F of 0 is 0 plus f of 2. 2 which function you will take? Greater than 1, less than equal to 3. 2 becomes between 1 and 3. Na? So 2 square, 4 plus 5. 3 5s are 15. 3 5s are 15. Oh God. Okay, 15 plus 4, 19 minus 2, 17. Okay, 17 will be the answer. So, this is a composition of function. So, might be a possibility in the board exam they might ask you this type of questions also, but algebraic only you have composition of algebraic functions only, not of trigonometric and all that thing. Okay, I hope you got this point. So, this is the way. The next one, this is the answer here, see. R is reflexive on finite set A and having n element, and let there be m ordered pairs in R, then m is have nothing to do in this question. R is reflexive relation on set A. Okay, so set A is there. Okay, they are asking you set A. So tell me whether is m is equal to n, m greater than n, m less than equal to n. Now it is saying reflexive relation है. Reflexive relation क्या होता है? 1 1 2 2 3 3. So देखो, if suppose it is 1 2 3 and it is 1 2 3 from I think on finite set A. So A to A दिया है. So 1 1 2 2 3 3 हो सकता है ना? Right or not? Okay, having n element. So यहाँ पे 3 elements है, यहाँ पे भी 3 elements है. Then let there be m ordered pairs. That's fine. So m ordered pairs. So look at this. This is m ordered pairs and this is number of elements. Ordered pair and number of elements. I don't know why they are comparing it. Number of ordered pairs and number of elements in set A. When it is possible, when it is m is equal to n, I believe m is equal to n should be the output. I don't know, I am confirming that. M is equal to n, possibility is there. But you know, when I look at the question options, I always think twice before tick mark, because see, I can tick mark right away. Okay, so m is equal to n is there, but here also option is greater than equal to, here also option is less than equal to. I think, do you need any explanation here? I think this can be the case. This can be the case, reflexive relation, because यहाँ पे अगर they think m set of ordered pairs, let R be reflexive on finite set A having n element, so n is equal to 3, and let there be m ordered pairs in R and it is reflexive. Reflexive दिया है, R is reflexive. So हो सकता है 4 4, if is it possible greater than equal to n? I have a feeling there, I don't know, but think over it. Okay, now here let me not. Okay, so you understand this point, because in this case what is happening, I will tell you. See, R is reflexive relation, so the minimum number of ordered pairs will be n, because n is here, n is the number of elements, correct or not? Minimum at least 3 ordered pairs. 3 से ये नहीं हो सकता है, because ordered pair cannot be less than n. देखो अगर 1 2 3 है, तो रिफ्लेक्स होने के लिए 1 1 2 2 3 3 होना जरूरी है. मिनिमम होता ना वो मिनिमम. So the ordered pairs will be minimum 3 ordered pairs, because there are 3 elements. If there are 4, there will be minimum 4 ordered pairs, because to make it reflexive. So as I mentioned, reflexive. So ये option out of question हो गया, ये option out of question हो गया. Now here either this or this. So m is equal to n ने हो सकता है कि more ordered pairs can come. Relation में क्या होता है, I will tell you. See, any relation, ये अभी ये 1 1 है, 2 2 है, 3 3 है, और 1 2 भी हो सकता है ना, 2 3 भी हो सकता है. So in this relation, this is reflexive. So reflexive मतलब other set of ordered pairs can also be present. So I mean to say the number of ordered pairs will be greater than or equal to the number of elements minimum, that is 1 1 2 2 3 3, right or not? So I believe the first option suits very well for this particular thing, because m is equal to n out of question हो जाता है इसमें. Number of ordered pairs cannot be equal to number of elements, because for reflexive 1 1 2 2 3 3 है, but other ordered pairs also will be a case. So this is m 1 2 3 4 5, 5 ordered pairs, m is 5, n is 3, that means m is greater than n. Or in the case if it is only 1 2 3, 1 1 2 2 3 3 is also possible. So greater than or equal to this suits better than this. Okay, got the point? Okay. This domain ka part you can do on your own. Okay, I think I will share these questions with you. You can try it out of your own, on your own. Now look at this. This sum is very easy question. This question we have done already. Okay. The relation R is defined by R 1, 2, 3, 4. Then R is what? Reflexive, transitive, symmetric. क्या हो सकता है? Right? Think over it. It is defined by this is a simple question. यहाँ पे 1, 1 नहीं है, 2, 2 नहीं है, reflexive नहीं हो सकता है. Symmetric देखिए 1, 2 है, 2, 1 नहीं है. Symmetric भी नहीं होगा. Then transitive हो सकता है क्या? 1, 2 है. AB है, BC नहीं है तो AB को ignore करो. 3, 4 is there. BC is not there, इसको भी ignore करो. So that means this will be the case of transitive. Because see, AB है, if BC is not there, don't look, ignore these ordered pairs. So it is transitive. So I think it is transitive. Okay, keep that in mind. SIT. Okay. Then this you know already how to do it. This is also simple question, tan inverse x plus A. If you try it out, because I think this there is no need to do it. No need. Okay. Then this A contains 4 elements, B contains 5 elements. The number of 1, 1 and on 2 mappings is what? Number of 1, 1 on 2. I think I had given you this. Can you maybe tell me? Can you go through the first notes which I gave you? If it is said a 1, 1, pocket concepts will always be there. There is no need to do it. If you want to do it, it's slightly different. This is a simple question. This is a simple question. This is a composition one. This is also, but here the function is not given to you. Let's think over it, how we go about that. So children, I hope you understood the first step, the first part is important. This notes, I am coming to that. It's very, very important. Many questions will be able to solve with this. So basically, we are looking at this concepts only. We are not thinking anything more than that. And this is the way you go about it. So any question out of this set which you don't understand, please let me know. I will be more than happy to help you solving that particular question. Okay, children. So thank you very much for joining. Tomorrow once again we are going ahead with reflexive, day after tomorrow once again we will be having relations and functions only, because I want to focus on this, and then after that we will start with. So next lecture Wednesday, don't come for offline class for now, at least till Diwali. Okay, after Diwali we will catch up with you and we will have offline classes, all of you. Okay, so that's the way it goes, that's the way you put across. I hope you got this point of view. Thank you very much for being with me, children. God bless you. I am there for you. I will share some more MCQs with you in the next session. Now I hope little bit an idea you got how you really come, and these are difficult questions. These are definitely difficult questions, and definitely in the board exam it will be more simpler than these questions. Okay. So thank you very much for being with me once again. See you. Bye bye.